Hello everyone. In today's session, we will discuss about the runoff. Basically, the runoff is the most important term because whatever the rainfall or the precipitation occur over the land, some amount of water infiltrates, some amount of water evaporates, some amount of water transpires through the plant, and the remaining water basically flows over the land. And the calculation of this water in the form of runoff in terms of depth or in terms of volume is very important, because when there is a flood or situation, basically this runoff, because of the runoff only large quantity of runoff in less duration, basically flood situation occurs. So that's why this runoff term has a lot of importance, and we will also discuss about the hydrograph. But today's session is we can say it is the foundation to learn about the hydrograph, because before hydrograph we should understand each and every terminology from the runoff. So let us discuss on runoff. Now in this particular figure, actually here you can see that this is a watershed, this is a watershed boundary, and here actually you can see the same watershed. Now here you can observe this is a river and there are the small streams. Basically when the rainfall occurs, the precipitation occurs over this particular catchment, then here from direction you can understand that water is coming from this part. So basically what is the boundary of this catchment is this one. So this is the boundary of the catchment, and the dark green part is not this boundary. This dark green part is not the boundary of the catchment. Why? Because if you see the arrow, whatever the rainfall is occurring in this particular area will not be the part of this stream, but whereas from this place water is coming and become finally part of the stream. But whatever the water is falling in this green area, this one, it may be the part of other watershed, or maybe the part of other stream, or it may be the part of the same stream, but it will not come through this particular boundary, it will come from another boundary maybe. So that, because this is the natural boundary. Now from this arrow we can understand that this is the particular boundary of the watershed, and water is flowing and become a part of the small stream. The small stream meets together and form larger stream, or we can say river. In the same way, suppose this is the watershed. How can we define this watershed? The area having a single discharge point is called as watershed. Now in this particular figure you can see, I'll just select the pencil. So this is basically outlet of the watershed. So the area having a single discharge point, and for this, in this case, this is a discharge point. So the area having a single discharge point. So the area having a single discharge point is called as watershed. So what is the outlet of watershed is basically, so this, in this case the outlet is this one, so this point. So whatever the rainfall occurs in this particular area will become a part of these streams, and so these are the streams. So water is basically coming from these different streams. So I'm just showing the arrows from where it is coming, and finally it becomes a part of this particular stream, and it will go out from this outlet. Now the most interesting term is, basically if we measure the discharge at this particular point, then whatever the discharge would be there, it is nothing but whatever the water is collected from this entire boundary, out of this entire boundary. But as we know that some amount of water infiltrates, some amount of water runs over the land, then for different area, depending upon the geological condition, type of the soil, actually this generation of the runoff, or we can say the runoff coefficient, vary. So now we can do the stream ordering also. So basically there is a rule for doing the stream ordering. So what is that rule? Is basically when the two streams having the same order, and when these streams combines together, it is called as then it can jump into the next higher order. Suppose if we just take example of the just a minute. Suppose if we take example, suppose this is one small stream, and we can mention one number. There is another stream, here also we can mention one. Now when these two streams having the same order combines together, then forms the next stream called as second order. So higher order, the next one. If this is a stream, we can mention here one, the single stream. This is also single stream. This stream is also single stream. This is also single stream. When 1 and 1 combines, it jumps into the next order, that is 2. When 2 and 1 combines, then it flows with the highest order. From here it is coming as a 2, here it is coming 2. So 2 and 2, then it next to the jumps to the next higher order, which is 3. This one is the 1. So when 1 and 3 combines, then it will go with the 3 only, that is highest order. Here also this 1 and 3 combines, it will go with the highest order. And so finally the watershed having a order 3. So how can we define, or how can we find out the watershed order? Depending upon what is the highest order of any stream, whatever the streams are there in the watershed, so the stream having a highest order, so that is the order of the watershed. So basically why we are doing this 1 2 3 4 whatever it may be, basically from this we have the idea that what kind of quantum of the water will be there depending upon the order of the stream. We may not get the exact quantity, but it will help us to quantify the water, or to just get a judgment about the quantity of the water. So once again I'll just repeat in short, like if there is a simple rule, if the stream having a same order combines together, like 1 and 1 combines together, then it jumps into the next higher order, which is 2. When 2 and 2 combines, it jumps into the next higher order. But when streams having a different stream order combines together, then it will continue with the highest stream order. So here in this case, when 2 and this 1 combines, it goes with the 2 only, but at this point only. But when this 2 and 2 combines, it will go to the 3. When this 1 and 3 combines, it will go with the highest order, that is 3. So when this 3 and 1 combines, it will go with the 3. So like this basically we can do the stream ordering. This is very important. Now coming to the runoff. So basically in case of runoff, as there are the different terms that we need to understand, and so which will give us about the idea of the runoff, because in the runoff there are the many different types of the runoff. So we will see one. So there are the different terms in case of runoff. We will start with the basin recharge. So basically it consists of a rain intercepted by leaves and stems of the vegetation. Even when water held up in surface depressions, generally commonly it is known as a depression storage, or soil moisture held as capillary water in pore spaces of the soil, or as a hygroscopic water absorbed on the surface of the soil particles. So all these things comes under basin recharge. Whereas there is a second term called as direct. In case of direct runoff, there are the two terms. The first one is the surface runoff, second one is subsurface runoff. So surface runoff, what is meant by surface runoff? Surface runoff is nothing but the overland flow. So basically it is that part of the water which travels across the ground surface into the nearest stream. So here if we observe, so whatever the water is flowing over the surface is called as surface runoff. Now the subsurface is just below, when water infiltrates, and when it flows we can call it as an interflow also. Like because of the permeability of the soil, water gets infiltrated and it flows horizontally or parallel to the ground, but this subsurface layer of the soil is quite impermeable. That's why water can't deep percolate and would not become a part of the groundwater. So it will flow, and this flow is called as interflow as well. So this is nothing but the subsurface flow or interflow. The last term is there, which is percolation down to the groundwater. It is also called as base flow. Now in case of base flow, basically water goes to the down and becomes the part of the groundwater and then flows horizontally and become a part of the stream as well. So this is called as base flow. So these are the basically different terms. Now we will also discuss about some basic terms generally used in the hydrology. What is meant by basin, what is meant by stream, overland flow, like that. Now we will discuss a few basic terms used in the hydrology. So the first one is the basin. So basin is nothing but the catchment or the watershed. So that is what we have discussed, the area having a single discharge point. The next one is the stream. So now what is meant by stream? Basically whatever the runoff is generated finally becomes the part of the stream. So stream is a natural flow channel towards which the water from a basin flows, and the stream drains out the water so collected into a larger water body. So as in the previous picture, actually we have seen what is meant by stream. Then the next term is overland flow. So what is meant by overland flow? Actually, basically it is that portion of the rainwater which flows over the land surface is called as overland flow. Then the next one is the stream flow. So basically the stream is channel, and stream flow is something different than the stream. Then what is the difference between stream and stream flow? The stream is a channel, and whereas the stream flow is basically total runoff, consists of surface flow, subsurface flow, and groundwater flow or base flow. So all these comes together and we can call it as a stream flow. The next term is drainage density. So what is meant by drainage density? We can represent it by dt. So it is basically defined as the ratio of the total length of all the streams of the catchment divided by its area. So this area is this one, and total length of all the streams. So we have seen the stream. If we measure the length of the stream and divide it by the total area, we can find out the drainage density. Then next term is basically stream density, this one. So how can we define the stream density? Is basically the number of streams of the given order per unit area in kilometer square is of the catchment area. So we can define, like suppose stream density, we can mention like suppose, just a minute, I need to, what is meant by stream density? So basically the stream density is defined as the number of streams. So we can write the formula. Suppose we can mention like ds is suppose stream density. So we can mention over here suppose this ds is equal to, ds is basically ns by a. So what is meant by this ns is the number of streams of given order. So if order is 2 and whatever the number of streams are there, suppose 5, divided by the total area. So this is stream density. Then the next term is, and basically this number of stream is a number, basically in area is in kilometer square. Next term is the centroid of the basin. So it is the point of weighted center of the watershed, is called as centroid of the basin. Next term is form factor. So what is meant by form factor? Basically Horton is the scientist. He has defined form factor. We can mention with the notation as a FF, form factor. So form factor is basically defined as the ratio of the average width of the basin, so that we can mention by suppose WB divided by total divided by length measured between the stream outlet to the most remote point on the basin. So WB divided by, we can mention here LB. So what is this WB? So WB is basically average width of the basin, and what is LB? LB is the length measured from the stream outlet to the most remote point on the basin. So how can we define it? So for which we can draw the figure which will give us the clear idea. Okay, so basically this FF, this is form factor, is equal to WB divided by LB. We know WB is the average width, LB is the length from outlet of the this watershed to the most remote point. So from the figure actually we can understand, like suppose if we draw a simple figure of any watershed, suppose this is the outlet point. I have drawn just irregular shape, any irregular shape, and suppose these are the small streams. These are the small streams. Suppose this is the outlet. So from this outlet point up to the remote point, we can say this one. So whatever the length is there, this is LB. What is the WB? Suppose if we measure from this point to this point, this point to this point, and whatever the width we are getting, so average of this width is nothing but the WB. Okay, so this is also equal to, we can also mention, we can also mention that FF is also equal to, so instead of WB we can mention like A by LB, because the entire area divided by LB is the outlet to the remote point, divided by this LB, because in this way only we will get the WB, that is average width. So area divided by LB. So finally we get A divided by LB square. So basically in this way we can find out the form factor. The next term is actually this is whatever we have discussed now, it is all about the form factor. So I can just mention like this, so there won't be any confusion. Then the next term is compactness coefficient. So Strahler is the scientist. He defined this compactness ratio as a ratio of the perimeter of the basin to the circumference of the circle whole area in the area of the basin. So basically how can we define, like it is the ratio of two terms. The first term is perimeter of the basin. So perimeter of the basin is nothing but this perimeter divided by circumference of the circle. If we assume this as a whole circle, then what would be the circumference of this circle will be taken, and the ratio of this will give us the idea about how compact it is, how compact this particular watershed is. And for that also there is one formula. So I will write down the formula for this particular compactness coefficient. Is basically we can denote it as a CC. So compactness coefficient CC is equal to P by, so this P by under root of 4 pi A. Now what is meant by P? P is the perimeter of the basin in kilometer. A is the area of the basin in kilometer square. So from this we can get the compactness coefficient. The next term is elongation ratio. So whatever we are discussing right now, it gives us geomorphological characteristics. So all these elongation ratio, circulatory ratio, compactness coefficient, form factor, stream density, all these terms indicate about geomorphological characteristics of the watershed. So elongation ratio, like from circulatory ratio we can understand how compact it is, but from elongation ratio also we get idea that basically the formula for this elongation ratio is ratio of diameter of the circle of the same area of the basin to the maximum length of the basin. Okay, so formula for this we can mention it as ER, which is equal to, so this ER I will write here only. So this ER is basically equal to 1 by L square root of A by 0.786, and generally it is less than or equal to 1. So if you just put the value of area of the basin and length length of the basin from suppose outlet up to this the last point or most remote point, we can say, from which we get L. So, and if you just put this value 0.786, you will get the elongation ratio. Generally it is less than or equal to 1, so maximum it is 1. Then the last term is circulatory ratio. So this circulatory ratio is basically proposed by Miller in 1956. It is the ratio of the area of the basin to the area of the circle having the same perimeter as the basin. Okay, so how can we formulate it? So this compactness coefficient is basically CR. So this CR is equal to 12.57 into A by P square into this A by P square. It is basically also less than or equal to 1. So in this way we can find out the circulatory ratio. Now we have discussed many different terms. Now what we will do in the next session, we will solve the problems based on these terms. So I just tried to give you the basics of the any watershed. Like you may get a question like, suppose the length is this much, width of the basin is this much, find out the stream density, find out the elongation ratio, all these things. Okay, so from the obviously whatever the things which need to be there will be given to you, and based on that you are supposed to solve the problem. So next session we will discuss about the problems based on these concept. But in below link, actually I have given a link in the description. If you just click on that link, you will be able to appear for the quiz. In the quiz, just there are the 5 to 10 questions, but it will kind of revision what you have understood. You will be able to do this. These are the multiple choice questions. Thank you.